Welcome to the Troxel Podcast. I'm Evan Troxel. Troxel is the podcast where I have a conversation with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. I have a bit of housekeeping before I get into the preamble and introduce my guest for this episode. There's some new web pages on my site that I want you to know about. The first one is trxl.co/trxl. I've created a landing page for the podcast that includes some newly gathered testimonials. I recently reached out and asked for some, and the audience faithfully delivered in spades. I'm humbled, and I have much gratitude to those that contributed. And it's not too late. If you'd like to contribute a word about the podcast, please send your thoughts to my email at evan@evantroxel.com. That's evantroxel.com. There are also some links on that page to other podcasts that I've recently been on that go behind the scenes and beyond the scope of this show. And I've also included some fun factoids about the show there as well. Again, that's trxl.co/trxl. And one more new resource on the site that I want to tell you about as well, the Troxel Episode Database, or as I call it, the TED. You can find it at trxl.co/TED. TED is a comprehensive listing of every episode of the Troxel Podcast that's been published since I launched in June 2020. There's categories, keywords, guests, a search box. If you're looking for it, you will find it there. So again, that's trxl.co/TED. Okay, that's it for the housekeeping. In this episode, Brian Ringley returns to the podcast for another round. Brian is a construction technologist at Boston Dynamics, where he manages the Spot autonomy product development for dynamic sensing in changing environments like construction sites. Before coming to Boston Dynamics, he was a construction automation researcher in commercial real estate at WeWork. There, he piloted emerging construction robotics products and stood up a factory for the industrialized construction of office space. He's also been a visiting assistant professor of architecture for many years at Pratt Institute and was a computational design specialist at international architecture firm Woods Bagot. You can hear his origin story on this podcast in episode 28, which I've linked to in the show notes to make it easy for you to find. In that one, we talked in depth about connecting the dots between all of Brian's interests and experiences, and is a good precursor to this episode, and I highly recommend listening to that one. You can find that episode and more at trxl.co/TED, which is the Troxel episode database I mentioned just a minute ago. The conversation we have in this episode connects ideas in articles Brian wrote for Architect Magazine and Engineering News Record, which I've also linked to in the show notes, with the release of Spot 3.0, Boston Dynamics' mobile agile robot platform. Today we talk about Brian's notion of continually as-built models as digital twins via the pairing of artificial intelligence and mobile autonomous robots loaded with sensors like Spot. The concept of digital twins as a building operating system changing the design and delivery procurement relationship with owners. How companies in AEC can use robotics today to transform their business and enhance revenue generation. We wax nostalgic, but mostly poke at the glorified master builder concept in light of BIM and emerging technology. The use of robotics as a means for achieving that so-called utopia in a dynamically changing environment like that of a construction site, both in a robot as skilled trades provider way versus the much more likely and pragmatic robot as early warning system / robot as early warning system / observation tool way. What's involved in designing the mostly unseen mission planning and tool paths in a file-to-field approach when we as architects can't participate legally in means and methods, for example. The agency architects can find with new tools like AI and robotics, and so much more. So without further ado, I bring you Brian Ringley. Brian, welcome back to the show, and thanks for taking time out of your whirlwind tour to speak. It's awesome.
Yeah, of course. Thank you so much for having me and for giving me a much-needed break from a Vegas conference.
Well, Vegas during the day is very different than Vegas during the night, right? So at least
different variations of
something to look forward to.
Different variations of sadness, I suppose. The music changes a little bit. The lighting, however, does not.
Right. Yeah, it's more colorful at night though, for sure. It's
are you talking about going outside?
in many ways. Yeah, there is an
I always
outside
forget
there.
that.
There actually, yeah. But yeah, there's many sides of Vegas, right?
That's right.
So,
Yeah.
many. But that's just one of your stops. You're all over the place, and you're really out because of this. So I assume you're showing off new capabilities of Spot and all that. And I would love to get to what that is. I think the last time you were on the podcast, we barely mentioned robots, and I would love it to be mostly about robots this time, just to give.
Oh, that's right. Yeah, I think I told my whole life story on that one. Now we can just
right.
Okay, we got that done. Episode 1. Now we can actually talk about robots.
It was worth it. It was worth it. Yeah, I mean, we'll put a link to that one back in the show notes. That was the holiday extravaganza episode.
Right. If we had just waited 2 more months, we could have made that an annual occurrence.
No, it's 10 months is the perfect number because we don't have to drink the spiked eggnog this time.
That's true.
And,
this could be a spooky Halloween release.
Right. So let's see. You recently wrote an article. I don't know how recent it was now. Let me scroll up to the top of this.
A month ago.
This one that I'm looking at, Beyond the Master Builder, was posted December 15th, 2020, which is like right around when we.
Oh yeah, yep. That's what we talked about the first episode.
Talked.
Yep.
And since then, you've written some additional stuff, and you guys have come out with some additional stuff with Boston Dynamics and Spot Robot. So I don't know, where do you want to begin? I kind of, going back to that article, I love this kind of idealized state that you talked about, and you posed an interesting question. The idealized state is that of like the super cliche architectural the master builder, which is this idealized utopian. Wouldn't it be cool if we got back to that? And
for some, yeah.
For some, and let alone like all of the ways that we've done everything possible to get away from that, and what the repercussions of going back to that might be are pretty unfathomable at this point. I think just with the complexity that construction has become.
Yeah, that ship has sailed.
Everything. Yeah, it has. And yet there's still quite a bit of talk about that, and if only we could get back to that.
Yeah.
And then just all of the automation and technology that's happened in the last decade with this kind of file to field approach that you mentioned in that article, and let alone how broken the design bid build delivery method is for anything like that to actually work well. And then let alone means and methods as well, right? Which is prohibited, and there's all of these kind of things working against us when it comes to that idea. So maybe you could set the stage of where you were going in that and subsequent articles to set the stage for automation and robotics in architecture and construction. I know you're mostly focused on the construction side of things, it seems now.
Yeah, trying to drag a few architects in kicking and screaming, but yeah, mostly construction. Yeah, that article was also my apology, because it was based off of my career trajectory of trying to drive a linear design to delivery process down people's throats and thinking of the model as something kind of holy, and building a lot of intelligence into that model, and thinking that, design intent, could in fact be reality if we just set up the right processes. And then I spent actual time in the field, as everyone should at some point, and really, thought about what the trades had to offer in terms of their skill set, and also thought about the efficiency of abstracted design documentation. The fact that some of our most compelling structures in world history were built with, just a bundle of drawings and did not require LOD, Infinity, BIM, and augmented reality on site to implement. And I always thought it was a little bit of, I think we've lost that, right? We've lost that level of abstraction, which leads to a kind of information efficiency. And I think it's important. And I think that can still be reclaimed. I think it's like an interface issue. It's not like a BIM issue. It's how we interface with BIM. So I was thinking about all of those things and thinking about, switching from this idea of design to delivery as linear to something that's a feedback loop. And how do we get that feedback? And the other thing that was happening at that time at WeWork was I was really enthralled by the reality capture team there. And Case had started doing some laser scanning before they were acquired by WeWork, and that was like a service they were offering. And I had the hunch. I was like, it was the same way I felt when they were doing BIM, which I was like, what's this BIM thing? Like, who cares? But they were really ahead of the game, I think, with that and its mass adoption in industry. And I felt the same way with laser scanning, where I was like, why are they doing that? Like, that seems awful to, go out there and try to digitize this stuff. What's the value of that? There's this pattern in my life of me realizing the value of things like, 3 years later and then writing articles about it.
Yeah, same.
So the reality capture team at WeWork was incredible. But there was a problem with getting us information quickly enough. How do you capture it? How do you deliver it? How do you analyze it in a way that actually adds value to a project and not just get it as okay, let's make sure there isn't a column shooting through a desk at this point kind of thing, which is about all you can do with it at the end of a project, especially because we were often designing and doing fit out well before we even had access to the site. So we didn't even have reality capture data until we're halfway through. So all of that stuff kind of came together. And I had also been teaching and thinking about, robotic manufacturing and things of that nature. And I just wanted to put all of these ideas together, which is that, hey, I believe in the power of robotics to fundamentally change the way we deliver buildings. I think that there's a huge fixation and a somewhat misguided fixation on the idea that robots are building things. And I think we need to utilize the knowledge of the trades. It's going to help us on the design and documentation side because you can be clever about what you leave open-ended, what you leave a little bit undefined or abstracted for them to do in the field. But that only works if you get a high resolution of what actually gets deployed in the field back into the model. And you need some kind of positive feedback loop. So there really isn't an effective way to do that. In terms of, you don't want to carry an SD card from a scanner back and forth, and you don't want to go out and do the actual capture itself. So these are the steps that need to be automated: the planning, the capture itself, whether it's scanning, 360, et cetera, and then actually sending that data from the job site. Presumably, job sites aren't super well connected, but presumably you can go somewhere and get some kind of signal or use the spot doc as it were. But that data needs to get sent back to the cloud to then run analysis on it. And then the feedback loop there is the fact that you just have streaming data from the field. And this is an aspect of the digital twin, right? Is that you're actually getting it streaming in real time or near real time, and you can make decisions with that. And I think we think a lot about IoT sensors as static sensors that are deployed in a building after it's constructed. But what if there were a way to do that with dynamic robots doing dynamic sensing in highly dynamic environments? And that was really what I started to say, is that, hey, there's this huge opportunity here for the adoption of robotics and AEC to accomplish just that. And then the article goes on to say, who's actually responsible for that and who stands to benefit from that, who wants to take on that risk, but who also sees, a way to maybe create additional services, generate additional revenue, or implement better quality control in some of the things they're already delivering. So I think for architects, I was saying there's obviously enhanced construction admin. And if the model can stay live, the ability to, use parametric models to react to in-field changes. So not just saying, all right, I've got a parametric model that reacts to design input, but I've got a parametric model that reacts to whatever was physically built, which I have from reality capture input. And then I also talked about relationships with owners, which is that I think that GCs are pretty aggressively moving toward the idea that an owner is a lifetime client, and that projects are life cycle projects. So you're not just delivering, but you are working with them to operate that building and using some of the same reality capture and BIM and IoT technologies to do so. For me, that's really where the digital twin kicks in too, is there are aspects of that are useful in construction, but it's mostly, for me, it's a kind of complex building operations tool. So that was that article. And then I wrote one for Engineering News Record, I don't know, 2 months ago, something, August 11th. Wait, oh my gosh, what is time? So I guess August 11th, which is called Today's Opportunities for Tomorrow's Digital Twins in Construction, because I wanted to elaborate on, because the whole point of like, oh, this is how I see robots being used in architecture and construction, which is to build this feedback loop. But that feedback loop is an element of the digital twin. So I was like, well, I should kind of, write the 2000th think piece on what a digital twin actually is, because we need that.
Thank you for your thought leadership.
Yeah, I better jump on that. I was like, oh, I got to get my AI article done too. But I thought it was important because, I mean, it really is what you're doing with Spot. So the reason I say today's opportunities are to say there are things that you can do with robotics today that set the foundations for, I think, what are more aspirational goals with digital twins in the future. And then again, who should be using this and who stands to benefit. So I also talk about like, yes, there are complex construction operations that benefit from a twin. I don't think like just doing continuous reality capture in and of itself is a twin. It's twin-like. And I think that's really the goal for a lot of construction operators, is to have that in combination with some AI that gives them some kind of insight or report, right? They're not just collecting data. They want to know how much work is in place, what mistakes were made, if they're staged properly for, the next set of subcontractors come in the next day. But, to then combine that with like fixed building systems, environmental controls systems, building security, tenant access systems, parking systems. There's like so much stuff that can go into a building. Like, and that's just a typical like commercial building, and then you have like the petrochemical factory, which has all sorts of other data layers to it where like, yes, you obviously need a digital twin there, but just posing the question, how complex of a project do you also need for this to be valuable? Because it's a lot of work. It's less work if you plan for it from the beginning, right? And I don't know, one of the questions I like to ask customers is like, how much are you thinking about data capture and pre-construction? Are you actually pricing this out? Do you know, do you have a capture execution plan the same way you'd have a BIM execution plan, or, converge the two? And really think about that, because I think if you just say, you get to the end of a project and then you build a digital twin for the owner, I'd be like, oh, like no way. Maybe for like a few complex projects, but that's way too much effort for most buildings. But then if it's part and parcel of this process I described in the first article, where you're starting to use a robot to just kind of keep track of what's going on, and you get into this routine feedback loop of reality capture data, and you have a, continuously as built model. That's what I'll say is digital twin light would just be continuously as built model. Well, then there's arguably a lot less effort to put into transitioning that into something that works as like a digital twin in building operations. So you've kind of set the stage for that. There's a lot less expense that would have to go into that juncture between delivery and operations. And therefore you could open up uses for the digital twin for less complex buildings and for commercial buildings. And everybody could kind of stand, or most people could stand to benefit from those systems. So that's really what that dove into. I felt like I needed to elaborate a bit more on, what do you do during delivery, which is really the first article, and then how does this help at delivery and after delivery, which is the second article.
I'm curious to hear if you've gotten feedback from the various audiences, either architectural or contractor side of things, for as far as like the practical realities of this go, because that's really what you're posing as the question is, how could you use this today for some future benefit? And everybody's going to be, being the different audience that they are, is going to have a different idea about what that could be. And having that as a goal is still a very different thing from actually doing it. The day to day, like you said, you're capturing all this stuff. What do you hope to do with that? And what is it going to take to deal with that? Yeah. Or kind of from two different audiences in this regard is they're going to have different ideas about that, but also different challenges to actually go through with that.
And we're going through some different phases, right? I think the pandemic and quarantine and reduced access to site brought like stark light to the need for some tool for remote access to the job site. So that's it's like record keeping. It's virtual documentation. I think a lot of companies benefited from that. So we saw the like meteoric rise of applications like HoloBuilder, OpenSpace, Instruction Site, et cetera. And that was good. And I think that then drove quite a bit of, business and conversation for us at Boston Dynamics as well, because once you realize the importance of remote access to your site, you then in turn need to understand how to capture that data to build that remote access. It doesn't build itself. So
yeah, I wanted to get there for sure, because we just lightly mentioned this whole idea of robots building buildings, and can you imagine designing all the tool paths to actually make that happen? I mean, you know better than most people, like the whole kind of abstraction layer of designing the pathways that the tool follows to accomplish the task is a thing. It's a design job all in itself, and there's probably lots of failure in there that you have to deal with along the way to compensate for, to actually get what you wanted out of it. I can't necessarily imagine doing that for all of the various skills that are needed on the job site that those subcontractors do bring on the day-to-day. And it's just in them. It's inherent when you hire them that you're going to get that expertise because they already know it. And so, like you said, it doesn't happen on its own with a robot. It doesn't figure it out all on its own, even though it is loaded with sensors and it can see a bunch of stuff. And actually to accomplish a mission, it takes quite a bit of planning ahead of time, which is a design exercise all in itself.
Yeah, absolutely. And, learning to help robots plan, right? That's kind of the first serious foray for the AEC industry in terms of, I would say like file to field with robotics. There's a lot of precedent for sending information to factories, sending information to, CNC machines and to ERP systems and things that you would need to run those offsite facilities. But the field is, I can't even really, I get the question all the time about robots doing trade work. And I'm like, I can't even begin to think about that. There are so many,
Yeah.
There's so many,
If you've ever done any of those things yourself, you know.
Yeah.
What's involved. Yeah.
I know what's involved. I also not.
And to be not skilled to do it, you would just like, where do you even start?
Well, it's like one of those things where it's like a extremely hard robotics problem for all sorts of reasons. And it's also like, why? Yeah. There's not a good why there for me, like to, completely eliminate field labor. There's a fantastic efficiency, productivity, and safety argument for taking labor off site, which will reduce how much is required in the field. And that's also why I'm like not convinced. I'm like, dude, is this really something you want to try to do in a dynamic environment? Like, have you ever tried to autonomously walk that environment, let alone perform highly precise work in that environment? And, the only technology that really works for sub-millimeter precision, which is, not required for everything, but is required pretty consistently for like layout and certain operations, certainly sub-centimeter. That you need a total station for that. There are not like magic SLAM systems that can do that. Even if you had GNSS, probably wouldn't do that. And your GNSS starved in a lot of these environments anyway. But I don't like to get too hung up on the technical stuff because I'm also like, well, why would you? What's really the point? What's really the value? How does this make everyone's lives better? How does this help make a better built environment and a better work environment for the people who deliver those buildings? So yeah, I just switch over to the data capture side and then say, okay, well, there is still, I think, well, we can also talk about like, since we last spoke, like what have we done with the robot? I think when we last spoke, we were on the 2.0 software. The robot would follow a single path that you would plan. You would record that single path, and then it would avoid obstacles on that path within reason, not full blockages, but obstacles. And you also required some kind of network connection to be able to run it autonomously. And well, guess what? A lot of job sites don't really have that. And we didn't have the dock out, I think, at that time either. So you couldn't establish that through a docking mission with like a high-speed gigabit Ethernet connection, should you have that available somewhere on site. So there were a lot of limitations there. Inevitably that would fail. And there wasn't enough flexibility. So we had to, I was kind of spearheading things that were things I think we'd wanted in the product since, the days when I was a customer, like in 2019, which was flexible autonomy, decoupling an explicit path from like an overall map that would have lots of path decisions, the ability to edit what you do. So having advanced knowledge of the site, turning things off, or adding things later because they weren't initially accessible. And also dealing with this fact that like, I'm not going to solve the like job site telecommunications problem anytime soon. So just allowing the user to turn that off, and the robot is truly autonomous.
It's just point. The note in the documentation is by others.
So yeah, I mean, so now the mission paradigm is that you record a whole area, which creates a variety of path options under the hood. You record all of your desired data capture actions, and then you sequence the actions, and the robot takes, if you allow it, if you turn on these options, it can still work the old way because that's useful for some people. Then it will hit each action in sequence as you've indicated, and it will take shortcuts wherever possible. It has features that allow larger obstacle avoidance than before that you can turn on or off. It has features that allow the robot to do a little bit of exploration in its area to find an alternative route that wasn't explicitly recorded. There are these simple situations where it's like, there's a second open door, just like pass through there. So that's kind of an example. It's not like wandering off. And then there's also the full building rerouting, which is my favorite, which is it will, continue to like turn around and follow alternative routes and replan on the fly. So you'll have your initial path plan that you send out, but it will replan on the fly because a door got closed. Someone parked a scissor lift in the way. There are thousands of reasons why a robot wouldn't be able to walk the exact same path on your job site. So it will find another route. And sometimes it takes a while. I was on site with a customer beta testing it over the summer. It's a complex hospital site. They recorded the mission before they hung the doors. The doors were hung, and I think like 12 of them were closed. And the robot still got all the data points, but it turned like a 20-minute mission into like an hour and 15-minute mission. And then I looked at the operator and I said, well, you wouldn't be here to watch this, so it'd be a lot less boring. So it wouldn't matter that much to you anyway.
So how does, I assume that it's kind of, this feedback loop is also informing itself for its next mission, because there is not a series of models at all the different phases of construction, unless the contractor is doing some amount of this on their side of things. Like the architect does the design intent model, it's a complete model, and construction happens in a sequence and with phases and with trades and all these things. And so as the robot is walking the site based on some model that somebody is using to plan the mission, you're never going to use the complete model to do that, because that would be like you'd be sending the robot possibly to its death. So how like self-informing is this along the way?
Well, let's take a step back and talk about like, future autonomy with BIM. So right now, BIM is not involved. You do not plan missions from a model. There are a few reasons for that. The models are not interpretable as like a map at this point by default, and they're simply not accurate, right? If you use a model to drive a mission with a legged robot, even if everything in the model were correct, even if you had time-based information in that model that would say this is when this wall gets built, it's not going to have like the junk that the contractor left on the floor. It's not going to have the pool of water from the wet sawing that just occurred.
Yeah, this is the dynamic site that you're talking about.
Yeah, and the terrain matters a lot too, right? It's not just about the fact that all the features around the robot are changing. There's terrain, there's equipment with dynamic obstacles. So you can't, again, like it gets back to like the model is like an abstracted intent mechanism that does not accurately convey the real world. If you want a robot to walk around your site, you need real world information. So that said, there are ways that you can use our SDK and direct something out of BIM. I just don't think it would be successful the way that recording a mission in person, recording a map. Well, I suppose you could record it remotely too, but driving the robot around with human intelligence to record the map, to record the data action points. I think yes, in the future,
kind of establish that baseline.
Yeah, I think in the future, like this will be connected to BIM in some way. I just don't think that we quite have the requisite feedback loop for that. For one, we're going to need BIM systems that can simultaneously handle design intent information that's rectified or corrected or augmented with reality capture information, not just to say that like, yes, this wall was placed or this wall wasn't placed, but to also be like, yeah, there are 3 backpacks on the floor in that doorway. And I think that's
exactly where my teenager leaves them too.
He's trying to robot proof your house, but it's not good enough. So I think that we're missing platforms that do this. There are people out there working on this problem. I mean, Trimble in some respects has some kind of analytics and cloud compare stuff and BIM to cloud compare stuff. Avere is hitting this really hard in terms of how do you update model information with point cloud data and even 360 image data. Scaled Robotics in the UK is really doing a lot with, how do you update BIM with reality capture and do that in a reliable way. So there's the foundation of establishing a rigorous reality capture practice, right? There's the capture problem. And that is, I would not say solved, but that is where we have made the most progress and where the robot's super valuable. And especially with the 3.0 autonomy, it can reliably get around highly dynamic job sites, which is incredible, by the way. Like I think about where this robot was, 2 years ago, a mere 2 years ago when I was doing proof of concept exercises with it on sites. It's incredible, and it makes me excited about what's coming. So once you have the capture problem, you have the ingestion problem, which is how does this actually get put into, BIM and related systems? So we'll just say like BIM very generically in a way that's useful and valuable. Once you have that system, the feedback loop and some kind of software platform capable of making sense out of reality capture layered with design intent information, then there's no reason that you couldn't be driving robots out of BIM and kind of controlling it out of those platforms. And, we're inching closer to that. So I feel very, very good about the capture side. I feel bullish on the ingestion side, and we're, actively working on that and working with partners on that. And then you can drive it out of your models. I'm just not convinced that the inability to drive a robot with Revit is what's blocking the adoption of these robots. I just don't think I don't think that's the big thing yet.
I want to continue talking about this stuff, but I want to jump back for a minute and talk about this master builder idea and say, with the lack of, with risk aversion and the potential for this to be an accountability device on all sides of the table, has there been a lot of pushback from that regard with adoption?
No.
Or are you only getting like the people who are just really interested in pushing the bleeding edge forward, really latching on?
Yeah,
to this?
I mean, we're definitely biased by having early adopters. We are moving into, I think, especially the fact that, Trimble has the ability to create a construction specific application and sell that as a solution, robot plus scanner plus software. That is opening this up to a much wider general audience, and we're really excited about that.
They don't have to piece it together themselves.
Yeah. You're just like, I want a reality capture robot, and you just get that.
Yeah,
and it's pretty great to use. It's operated through FieldLink, which people already use to operate a lot of these other field devices. And that, I think we're doing the official press release and launch like later this month, but we have some beta testers who have been using it. So I think that gets to a more general audience. So yes, like we'll probably contend with some of those issues more. I mean, this is again firmly in the wheelhouse of the GCs. No one I'm talking to is like seeing this as a liability. I think they see it as like they're like, this is my job. Like I need to run this site, and that means I need to actually know what's going on, and that means I need to get comprehensive data.
Especially when they're thinking of it as the life cycle of the client and not just what's the next project.
Exactly. Afterwards. Yeah. Like this is in service to somebody who's going to be running this building. They're going to want to know what's in the walls. Sure. They're going to want to know in the future, they might need to do a, slab penetration, and they won't have to x-ray that because they'll know where the rebar's set. But you could think of all sorts of reasons why it's good to have information, not just about like what physically is inside of inaccessible areas, but also when it was done, who did it. Like there's just so much information that I think is useful to capture there and have a record of. I think that what we'll run up against, once we have this feedback loop established, broader adoption, better tools for, dealing with reality capture as a first class BIM data citizen, we'll say, or building information citizen. Then the focus is going to be completely on AI at that point. because we'll have all the pieces in place and say, okay, well, I'm not collecting all this reality capture to make a museum of data and to just like have a bunch of storage on the cloud somewhere for no reason. I'm doing this so I can make decisions. And to make those decisions, I'm going to need AI. So in order to leverage AI, you have to have frequently captured, well-structured data, right? So we're working on that. You need to have interfaces that can actually analyze and report. So that's, again, back to kind of the ingestion problem. But if you look at specifically what kinds of AI we're talking about, I think initially we'll be talking about computer vision models. So there's a lot of interesting AI work in the point cloud world from laser scanners, but it's a little bit of a different animal than what we've got with the fairly mature field of computer vision working off of imagery data, whether that's regular images, 360 images, or 360 video frames, which are just more 360 images. And then you say, well, what's valuable there, right? It's like work tracking, catching mistakes. The issue with, I think, computer vision, we're in the very early days of computer vision. In fact, one of our feature releases for 3.0 was the ability to do what we're calling smart action. So now you're not just taking a photo, you're taking a photo paired with a computer vision model to answer a question. So, is there a fire extinguisher here? Yes or no? Or even, where is the fire extinguisher, right? So this object awareness, you can return the rays off of that object and get actual coordinates for objects in space, which is really cool. But to do really useful work, to say, I want to know how much drywall is up, and I want to know how much MEP scope is done, and I want to know how my flooring is coming in. Well, that's like at least 3 different computer vision models. And some computer vision problems require multiple models. Like I want to read a gauge. Well, you might want to have one that recognizes a gauge in the world and points at it and zooms in on it. And then you might want to have another one that actually reads the gauge and returns digital information off of that. So if you're same thing with fire extinguisher inspection, you might want to actually read the tag. So you might have to have a 2-step process there. And then when you start to think about it, all the things that we dream about doing might require thousands of computer vision models. So we're not there. And I suspect there will also be some changes to the core technology and the approach itself that make it so you don't need quite so many models to do kind of more generalizable things. But, I think we've set the foundation to say, well, you can take like a TensorFlow model and you can put it on board Spot and you can get answers at the end of a mission rather than running it through some software. But we also know that there are a lot of other AEC companies working on this that have like proprietary vision algorithms, and we'll say, okay, that's fine. You can take Spot data anywhere. So you can leverage that as well. It's a slight downside to that being siloed into some kind of subscription app. You could imagine a world where you have to have like 20 cloud app subscriptions to get all of the AI you want. So, but I'm sure leaders and winners will emerge over time. So I think my next, next thought leadership piece will probably be delving into that AI thing. Because when I get, toward the end of that digital twin article, it's like, well, everybody's like, what's the big payoff here? It's, well, you're setting the kind of structured data foundation to be able to leverage AI to get automated analysis and reporting. I think there will still be this kind of human factor where you're like, this is what I'm interested in based on my experience with construction. So for example, MEP, always harder, always more complicated. I want you to hone in on those systems, maybe even specific aspects of those systems. That's what I want to track. Yeah, I don't need to know, you could run like change detection algorithms on your entire model, but you'll just get a lot of like somebody's backpack moved 2 inches sort of thing. So I think there will always still be the human touch, which is to kind of govern, this is what matters to me. But then the rest of it, you want to be as automated as possible. And the whole point of this is to know what's going on a job site and to, prevent mistakes and, get to that point where not 85% of projects are over schedule, by the way. So you can see it's a long road. It's a road paved with a lot of single point solutions and a lot of, we'll say, unmatured technologies. But, by God, we're closer than we've ever been. And it's pretty exciting.
There's got to be some pretty intense barriers to that endpoint. Like I think about like what Tesla, how Tesla has gone from, cars, just electric cars to semi-autonomous, right? And they're dealing with, okay, so every car's got X number of sensors and they're driving the same roads as each other for, all over the place, but they're constantly comparing and contrasting what they're capturing and building these models and building the computer vision that can tell what a thing is and what to do about it as we get closer and closer to this autonomous vehicle, full self-driving, like level 5 type stuff. With a robot, I don't see a future where there's 40 robots roaming a building at night. Maybe there is. I mean, how do you get the amount of data that you actually need to do the type of training that you're talking about? Or is it not like that at all? Is it just way simpler than that as far as the number of capture devices?
Yeah, well, I like to think Spot is the center of the universe, but it's probably also not the only source of the training data. But I do think that, yes, it's a key technology for AI developers to be able to leverage. Imagine that you're a downstream cloud application that is, providing computer vision models, but, also has access to customer data in a, respectable and anonymized way to improve those models. You would love it if all of your customers had Spot, because what Spot leads to is consistency and regular and frequency. So now you're saying, okay, I'm not dealing with the weirdness of like human captured data, and the patterns there are highly irregular, both in the capture locations and the frequency of capture. I'm getting like,
I was thinking about just sending an intern out to measure for an as-built, right? Like that alone is like, yes, you can just say, go measure the thing, but what you're going to get back is going to be wildly different from person to person.
Yeah. So I think you get that level of structured data that really is essential to building models, especially building kind of new models if you're interested in asking like a new question from this visual information. So I do see Spot as like not the only path, but a kind of fundamental tool and a highly valuable tool for developers in that space. So while their customers are kind of solving the early problems of capture and ingestion, those people providing those end services, like where the data goes and where it's analyzed, could be benefiting from that data and should be, to be building better analytics and better AI off of that, so that we do get to the point where you just have a dashboard every morning that, gives you the overview. Here's how much of each trade is complete. Here's all the mistakes that were made that, need your attention. You could imagine something like Alice.ai being fed by this information to basically like, we're going to completely reschedule downstream. Because a big part of this issue too is like something goes wrong on site, and then it's like a domino effect. It's like, okay, we got a 3-week delay, no big deal. But that 3-week delay hits a few other dominoes, and then it's like a year on the end of your project. So you also have to have the ability to kind of rearrange the recipe, so to speak, of the rest of your project. And, whether that's rescheduling trade work, bringing different people in at different times, sequencing differently, as much as you can. It really all becomes a logistics game. And my goal is just to make construction pure logistics. It's just everything's built off-site. It's the logistics of getting it from the factory to the field. And then it's like the recipe for, the sequencing and assembly of that, and the field work that still necessarily will have to happen to get everything in place and finished.
Yeah, I mean, that's a dynamic system in itself. And you're talking about Spot as kind of this early warning system, potentially.
Yeah.
But I'm also wondering if there have been examples yet, or with the clients, the customers that you do have, where not only is it being used in that capacity, but also from a standpoint of, do new opportunities show up along the way that people are able to take advantage of because they're so much more embedded in the process of building by capturing this stuff all the time.
I'd like to think that that's, so we talk a lot about, some customers saying like, I want to run a, A/B comparison of like Spot doing a single scan of my building versus sending a crew out to do a scan. And I think that those exercises are, they can be interesting, but that's not what it's about, right? That's not really where the value lies. The value lies in fundamentally changing the equation, which is saying reality capture is so cheap and easy that it's just a background process that is running constantly as people are doing work on site. And that background process strengthens and reinforces and provides feedback to what we do so that, we're coming in each morning and kind of doing a better job of that. So I'd also like to think that it will increase awareness between stakeholders, awareness of what's actually going on site, and establish the thing that's kind of at the core of my passions, which is informing a model from the skills of the trade. Like I love the idea of like a super efficient model that's smart in all the right ways and dumb in all the right ways. Like like really clever omissions of data that get filled in by the right people and then captured by the right systems and then deployed with the right analysis.
Yeah. I mean, what you are talking about here is like this operating system idea that you have in your article. The operating system isn't just the final product, but it's all of these processes that are happening along the way that on some level they're holding your hand. In other ways, they're informing you about things.
Yeah.
It pops up an alert when you need it because you're going to break something, and it gives you the opportunity to continue or dismiss or whatever, right? Like this is the kind of stuff that you're talking about through the process of building.
Yeah, and I think I also want, I want people to come to terms with like this isn't a product. It's a series of coordinated services, sometimes with misaligned incentives that, happens to produce a building for someone. So if we think of that as a series of service models, how can we put in the right systems to improve those services? And I think that I'm a huge proponent of the productization of architectural elements. That was always the diagram we showed in WeWork presentations, is like, what if your building were just like the iPhone? It's just a bunch of parts that get put together and you could have a repeatable process. And it's like, no. But like the spirit of that remains. Like you can have a really rigorous process with a positive feedback loop that, hinges on data, specifically that reality capture data that injects the real world into your design intent. You can have productized elements, like something like what Intelligent City is working on. I do think like you can order buildings from kind of kits of industrialized parts. I'm okay with that, but there's still a kind of delivery coordination and assembly process that will happen as long as buildings are real and in the real world. They'll all be a little different. They'll all be made with different groups of stakeholders. So I think that there are so many things we can learn from industrialized methods and from manufacturing and that we can be inspired by that. But like we should always remain kind of conscious of this service-based model and realize it will be a hybrid approach. And as such, it will be a little bit more difficult. And I think this is why people say AEC is, technology laggards. And I say it's just a different problem. It's a problem we haven't fully gotten our heads around yet. But I think that a lot of construction technology is actually incredibly advanced. When I just look at myself as a product manager in like the construction vertical at Boston Dynamics, I'm like, everybody's already convinced that they need data. There are already like hundreds of platforms for the consumption and analysis of that data. We're just like plugging right in there. It's a perfect fit. Not all industries are like that. The utilities industry and the manufacturing industry don't quite have these like robust systems with like a bunch of like competition and VC investment and everybody in the field has handheld cameras and they're familiar with scanners. Like, I actually think this is like a highly, this is a high tech field, and we're able to actually believe it or not, plug robots right into it, whether it's drones or terrestrial robots like Spot. But it is an extraordinarily complex business model. And yeah, like we'll change that and we'll challenge that, and there will be vertical integrations here and there, but it's never just going to be that like buildings are produced the way cars or phones are produced. That doesn't make sense. That's not what buildings are.
It's interesting to think about it from that perspective, because I was at Built a few years ago, and one of the keynote speakers mentioned that there's this kind of industrialized manufacturing comparison always being made to architecture. Yeah. And he made the point that, architecture, buildings are made from thousands of standardized parts. Yeah. You talk about car manufacturing or phone manufacturing, whatever, you're talking about standardized units created from entirely custom parts. These are opposites.
Yeah.
It's interesting also to kind of think about it. I think about this a lot, which is we have a lot of product manufacturers out there who make components, but nobody designs buildings out of components alone. Like, yes, there are thousands of components. Sometimes there are hundreds of thousands of components, but designers of buildings think in assemblies, right? And so what you're talking about is kind of these pre-manufactured assemblies of parts, which are to some extent standardized and sometimes not, and then assembled on site. These are very different ways to think about what we do versus the manufacturing of any type of X thing industry.
And I think sometimes I make it sound like it's so easy also to do, like, just build a factory and build your buildings with a factory, like that offsite. Like I'm bullish about it. I think people are doing amazing work out there, but I also understand, like, it's a completely different capital expense approach for an owner and a GC. It's a completely different procurement approach. Like, there are a lot of challenges in moving in that direction. There have been some, interesting attempts by some really sophisticated GCs to kind of say, like, yeah, here are those assemblies, right? Like, we're out here, we're building, right? Or we're subcontracting the building of these buildings. We have kind of a more intimate knowledge of, like, what we can do in terms of constructed assemblies, standardized details, et cetera. There have been a lot of experiments with that. I was speaking with a client in Europe about this, actually, and they said, and then we turn around and we go to the architects, and the architects reject it because they want to do design. And it's the same. It's the same way that people talk about, like, Revit's not a design tool because I don't get that freedom of form. It's like the same fundamental issue, which is what's the trade-off and the value of that? We'll say freedom of form, which can mean quite a few things, with standardized components, modules, assemblies, whatever that hierarchy is of what's customized and what's not, but just saying, like, here's a bunch of stuff that you can use to make the building, and we already have the means of production for that. Or you can make the building twisty, and you can make everybody's lives a nightmare, but it makes for some cool Instagram photos later. So that is my very...
How do you really feel?
My very nuanced take on that. But, like, you can't, I can't be completely dismissive of form making and the value that offers to the built environment, but it does pose, like, a serious impediment in a lot of these cases. And I'm not just talking about signature architecture too. I'm talking about detailing, right? Like, it could be some garden apartments, but the architect wants to, they want to detail the balcony in a different way, and it completely blows up the ability to use, off the shelf kind of industrialized products and assemblies. There's not a good answer for that. There's kind of an obsession with mass customization as a way to solve that problem. But sometimes I think mass customization is just an idea. There are various levels of that available. And there's some interesting things that, like, product manufacturers have done with parametric software interfaces to try to make that possible. But, a designer in CAD or BIM can, really make anything, right? And then the rest of the chain has to respond to that. So I think it's interesting because, once again, there's, like, a little bit of animosity toward architects from builders for those reasons. But, like, understandably, like, that is the value or part of the value that the architect brings. But I do think architects need to think, like, really hard about those relationships. And I'd like to see more, like, joint kind of, I don't know, joint venture is the right word, but, more deep relationships between designers, product manufacturers, and contractors. If you could ever assemble the same team for more than one project, which is a challenge, like I think that could be a really interesting model. But I think you do also have to say there's a limit on like reasonable building customization, right? At what point is it like, whatever, there will always be like a niche market for somebody who wants to pay a little bit extra to aggrandize their dynasty with a twisty tower. Like, I don't think that's going to go away, but like the things I'm talking about are like detailing issues by the like talented and respectable kind of like, non-signature architects. Like, this is a problem in still the bulk of like residential and commercial construction. So how do we get around that?
And then, I mean, you start to open up another can of worms, which is like, I want to say throughput, but I don't just mean throughput. I mean like body of backlog. If you're gonna completely standardize an assembly process, then you're gonna build a machine that does that so well that you've got to make everything that in the future out of those things, and you've got to be able to do that for some period of time. And there are not very many buildings that have like a serial builder behind them that is going to just continue to do that, because there is so much variation in site, climate, zones, everything, codes, everything out there.
And I think for me, that would be like the tie-in point to, the ability to reuse building elements and to think of building products as things that could also be disassembled. And that's not a new idea by any means, but like no one does it, right? All buildings are garbage. Like you build a building and now it's a piece of garbage. There are very, very few examples of the built environment where like that still holds value and could be reused. It's not like directly answering your question, but I think it's a good tie-in for something else that's really important that we don't think about. And now this podcast episode is getting extremely broad and far-reaching, but there's some stuff I like about, like, I don't know, there's like work by Molly Claypool at the Bartlett where they think about the combination of like robotic construction and assembly, industrialized building components, reusability and reconfigurability. Then that's the stuff where I'm like, yes, like that is like awesome academic architecture. That is wild speculation that's not feasible today, that actually does feed into serious challenges faced by the built environment. And like getting back to that article, going out and like imagining robots that just like auto 3D print buildings or, do this and that, like that feels less, or which is to say robots can be doing building, but like you kind of have to link it to a few other important issues in construction for it to feel like a relevant research thread, and relevancy, qualified here by how it relates to the challenges of practice, which is arguable. But this is why I take issue with, or not take issue. It's not a personal offense, by the way. It's just, this is why I like question and debate additive manufacturing and construction, because I get a lot of like hand waving, like, well, in the future, the materials will be like recycled and stuff. And I'm like, I don't know. Like, it's just all the same thing all over again with when everybody got obsessed with like advanced composites, and, concrete is a composite, by the way. And it's just like, this is stuff that like cannot be broken down and effectively reused. This is stuff that even if you weren't talking about the environment, right? Just think about like having an adaptable building. Think about where we're at right now with all of this commercial office space that is like requires like so much demolition and work and design to reconfigure.
It's funny because as a practicing architect for 20 plus years, it seems to me like everybody is going towards, I just need a freaking flexible space, man. That's
weird.
Need. Right. That's it. Can I just have a warehouse, please? And that would be fantastic. Because, like, every building is a warehouse. That'd be great.
Yeah.
That's totally where schools go. That's where any kind of education goes, because they don't know what they need in the future, and they know they're going to need to address something that they can't foresee.
Yeah.
Just make it flexible. That's
like, I think we'll say like reusable building components. Isn't there like a jargon word for that? I'm like,
probably.
I forget.
I'm on
sure there are words for that. But like the idea that you could reuse and reconfigure, like there's obviously the
demountable partitions like that.
Yeah. Just like less garbage, which is nice for our dying planet. But I just think like there's just the issue of like the usability of the space. Like that's a sustainability issue, is like, is this building useful anymore? And there's stuff we can't predict too, like COVID and like a large remote workforce as a result of that will probably persist in, some ways, like in a hybrid workplace. And now these offices don't quite make sense anymore. So there's a lot of investment that would have to go into changing them. There was a like WeWork funded smart geometry project that I did with Giulio Brunaro and Maria Yablonina, who Maria is a robotics genius, by the way. And it was about this idea of like, can we do a demonstrator of like, it was a couple things we wanted to demonstrate. One was reconfigurability, and we used the office space context, but it could be whatever, right? And then we did like a robotic like fiber winding thing as like a proxy for whatever the construction system would be. We know that you're not going to be building buildings out of like paracord.
I lovingly call this the yarn wall.
Yeah, yeah. I think we call it soft office. And then a big part of that too was like using Andrew Human's human UI interface, because I was like, it's kind of cool that the occupants of the space could have design agency and construction agency through accessible software development with something like Grasshopper, and accessible like interface development by extending Grasshopper with human UI. So they could say, what do we care about? We care about thermal comfort. We care about being social as quantified through views of one another through our workspaces. We care about acoustic issues, and then find ways to encode that in the model and run a bunch of, generative design stuff, and then kind of use your human oversight to pick some good options out of that, and then just, print. Except it's not 3D printing, it's winding. The other thing we really liked about the winding was, even though it's not the way you would do it, it demonstrates a means of autonomous in situ construction that can be reversed. You wind something, you unwind something, the same robotic system.
It's also performance art, man. Like robotic performance.
It was. I would love to just have that like set up like in my house, constantly running for no reason. So yeah, there were a lot of like, that project's near and dear to my heart, because I feel like it explored a lot of things that I think are really, really important to me, and things I've thought about. And I was lucky to get to work with such talented people on that, and to be supported by WeWork to get that out there. But it kind of it's like an example of like, no, we're not, this isn't how we're going to build buildings, but the ideas are at the center of this. And it combines what I love about design computation and robotics and feedback and user-centric design and user agency and blah, 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 blah. So.
Yeah. Speaking of robotic performance art, have you seen the Disney Spider-Man robot?
No.
You need to see that. I'll send you a link to it. I'll put a link to it in the show notes, because for their Marvel area, they've got this. I saw a video of it. I thought it was a stuntman. Okay, I thought it was a person.
Oh, isn't like an
doing
animatronic?
It is, but it's a free flying animatronic, like in the movie where you see Spider-Man swinging kind of with all of these amazing kinematics, and they developed a robot that started out as this thing. I think they called it the Brick, and then they went into like a 2 legs with a kinematic controller to make it this thing that could swing from a web. And now it's this fully 3D printed parts, below the Spider-Man costume to give it the form. But it's absolutely incredible what it does. And they're measuring all of the real-time wind speeds and everything that it has to actually adjust for during the performance. And it's incredible what they've put together. And so, I mean, obviously very purpose-built. There's no autonomy other than adjusting to things like the environment in real time right then as it goes along this one flight path. But it's absolutely incredible what they're doing.
Maybe that's what the Tesla bot reveal will be next year, is like some kind of like beautifully choreographed like stunt.
Yeah. Cool. Well, I really appreciate this conversation. It was a lot of fun, and I appreciate you coming back and doing it again. And I felt like this time we got to go to the depths we needed to go.
Yeah, it was good.
That's fantastic. So thanks for hanging out. Is there anyone or anywhere online that you would like to send people to follow along what you're doing at Boston Dynamics, and or anywhere?
Yeah, I think the easiest thing is just to go to Brian Ringley on Twitter. I recently upgraded to like the pro version of Linktree. So nice. Added a few little icons there and stuff. But that's where I keep like all the latest articles and blog posts and webinars and stuff. So if this was not enough to be sick of me, there's hours and hours more of content available for you on the internet.
I think people could listen to this golden voice all day long, Brian. Oh, okay. So when is Designalize coming back? Come on.
We're just
fantastic.
Never. It's not going to happen. This is the definitive
Moved
answer.
on. Moved on. Well, I appreciate everything that you do and that you've done. It's been a fantastic journey to watch, and thanks for sharing it here.
Yeah, thank you so much for having me again. This was awesome.
Thanks for hanging out with us today. This show is part of the Gable Media Podcast Network. You can see all the shows at gablemedia.com. That's GABLMEDIA.com. You can help support what I'm doing here by leaving a 5-star review on Apple Podcasts to help get the word out, and of course, share it with your friends. I'd love to hear from you, so leave a comment on the website at trxl.co/podcast, where you can find every episode. You can also follow me on Twitter and Instagram and YouTube. Just search for eTroxel. Talk to you soon.